Hey guys, we're on Unit 6. This is day 6, and we're going to talk about the square today. But in our warm-up, we have a warm-up of a rectangle, okay, with diagonals AC and BD. And they're going to tell us that the measure of angle AEB, A to E to B, is 130 degrees. They want us to find all other angles again. So as soon as I see that 130, I'm going to go ahead and make the vertical angle 130. And the angle next to the 130, that forms a linear pair. See the line with the separator? So those two angles have to add up to 180. And so 180, take away 130, is 50 degrees. And so now I could put the 50 here and the 50 here. All right, so we got the middle filled in. All right, whereas we just got done with the rhombus, those would be 90 degrees. But in a rectangle, the diagonals, a property of the rectangle is that the diagonals don't have to be perpendicular. Okay. All right. We do know all the corners are 90 degrees, so that could help us out. However, we don't know how that's split. In a rhombus that we just got done with, those diagonals bisect those angles, they cut them in half, and so we would have 45s. But in a rectangle, that doesn't happen. All right. But what we have to do realize that in a rectangle is that the little pieces of the diagonal, okay, so like that little red line segment there, is equal to this line segment here, and this one here, and this one here. And what I'm going to do is I'm going to highlight this triangle here. And then I could highlight any of the triangles, but every single one of these triangles is isosceles, and across from the two equal sides would be the two equal angles, which are the two that I'm missing. So I'm going to take 180 degrees. I'm going to take away that 50 that's in the middle for the vertex angle and realize I have 130 degrees left in that red triangle, but that 130 has to be split evenly. And so when I split it evenly, I end up with 65. So this angle here is 65, and this angle here is 65 because they're across from those two equal sides. Okay? And in that triangle is identical to this triangle over here. And so if that triangle has a 50, a 65, and a 65, that triangle is going to also need a 50, a 65, and a 65. And so those two triangles have all the angles they need. All right. If we go ahead and we look at this triangle down here, you have to realize that that triangle is also isosceles because this is here is equal to that there. And so we're going to do the same thing. We're going to take 180 degrees in that yellow triangle, take away the vertex angle of 130 that they gave us, and have 50 left. But that 50 has to be split equally between the two angles, the two base angles. And so we end up with 25. So this is 25 and this is 25. Okay? The other reason why that has to be 25 is, remember guys, that this angle here is 90. And so 90 take away 65 would have left us with 25 as well. Okay, so just a different way of getting it. And then remember that the triangle on the top is an identical twin of the triangle on the bottom that we just filled in. And so if the triangle on the bottom has an angle of 130, 25, and 25, the triangle on the top also has to have an angle of 130, 25, and 25. And so now our rectangle is all filled in with all of its angles. Okay. All right. Let's take a look at the square. The square, guys, is everything. The square is a trapezoid. It's an isosceles trapezoid. It's a parallelogram. A square is a rectangle. A square is a rhombus. Okay. So I could define it in many different ways. But what they say is that it's a rectangle with congruent consecutive sides. A rectangle doesn't have to have all of its sides equal. It has to have its top and bottom equal and left side and right side equal. But a square has to have all of them equal. So a lot of people will say it's a rectangle, okay, because rectangles have right angles and so do squares, but with all of its sides equal. Okay. All right, so here we go. A square is a quad because it has 4 equal sides. A square is a trapezoid because it has at least one pair of parallel. A square is a parallelogram because it has 2 pairs of parallel. Okay. Let's see, what else can we say? opposite sides are still equal. However, the consecutive sides are equal as well. And so that makes all of the sides equal. Okay? And so that's the properties about its sides. All right. So it has all the properties of a parallelogram, meaning that it has two pairs of parallel and that opposite sides are equal. Okay. Except all sides are equal. And we'll come down here and fill that one in. Okay. That's one of the properties it gets from the rhombus, since the square is a rhombus. Okay. We could talk about the angles. In a parallelogram, opposite angles are equal and consecutive angles are supplementary. Well, that still happens in here, except it's a rectangle, and so we know that it has at least one right angle, but the opposite ones are equal, so then it gets two right angles. The consecutive ones are 180, so now it has three right angles, and then four right angles. Okay. All angles are congruent right angles. Okay. So that's properties about its sides, properties about its angles, and now let's go and move to the diagonals. So I'm going to draw the diagonals in. A square does not slant. It stands straight up is how I kind of refer to it. And therefore, I don't really care for my diagonals. I'm going to try to draw them a little bit straighter. It's a little bit better. Okay. The diagonals are congruent. They are the same length. And because a square is a parallelogram, that point right in the middle is a midpoint of both diagonals. Okay, the diagonals bisect each other. So I could put tick marks here and here. And because the diagonals started off equal, that is also equal to that. All right, so all four pieces of the diagonal are equal, kind of like how that happened in the rectangle in the warm-up. Okay. And because a square is a rhombus, we have the four right angles in the middle again because the diagonals are perpendicular to each other. Okay. And because a square is a rhombus, those diagonals bisect the angles as well. Okay. Diagonals bisect opposite angles. Okay. And so what happens in here is because this angle is getting bisected and it's 90, it's going to get cut into 45 and 45. Well, each angle actually gets cut into 45 and 45 because each angle gets bisected by the diagonal. And so there's what we have there. All right. So if you look at any one of these triangles in here, you're going to realize that each triangle has an angle of 90 and two angles of 45. And in a square, we can go ahead and say that we have four isosceles right triangles in a square. Okay, in a rectangle, they were isosceles. In a rhombus, they were right triangles, and now we get right isosceles triangles in a square. All right, so that could help us out if they ask us questions. All right, let's see if we can answer these four questions. Number one, if the side of a square is 4, find the length of a diagonal. So let's go ahead and draw a square. Again, you try to draw it so it has 4 equal sides and 4 right angles. Okay. And they're telling you if a side of a square is 4. So it doesn't matter where I put the 4. In fact, I could put the 4 on all of them since all sides are equal. They want to know the length of the diagonal. And it doesn't matter which diagonal you draw in because the diagonals are equal. So I'll draw this one in. All right, what we have to realize that we have. Doesn't matter which triangle you look at. But the diagonal is actually the hypotenuse of that right triangle. And so I'm going to take that triangle and pull it out of there, just so you can see that we have a right angle. Okay, and that we have a side here of 4, a side here of 4, and we're trying to figure out the length of the diagonal of the square, which is really the hypotenuse of that right triangle. And the one and only thing that we have that works on the sides of a right triangle is the Pythagorean theorem. And we're solving for the hypotenuse, which is C. So we'll leave C open. Okay, we'll put the two 4s for the two sides and for A and B. All right, 4 squared is 16, and 16 and 16 make 32. And we take the square root, and the square root cancel each other out, leaving you with C equals. And when we type in the square root of 32 in our calculator, you're going to get an ugly decimal. 32 is not a perfect square. And so we could leave our answer as the square root of 32 if we wanted to. Okay? With radicals, there is something called simplest radical form. And so we could simplify that radical. It's a process that you learned in algebra. Okay? When you were doing the quadratic formula, you would simplify radicals. And the way you simplify a radical is you find the largest perfect square that does go into it. So 32 is not perfect, but you find the largest one that is perfect that goes into it. So in order to do that, we have to know our perfect squares. So we start with 1 squared, which equals 1, and 1 is a perfect square. Okay? It's not used in the simplifying process, though, so we won't use it. But 2 squared produces 4, and 4 is a perfect square. 3 squared is 9. 9 is a perfect square. 4 squared is 16, and that's a perfect square. Okay? 5 squared is 25, which is a perfect square. 6 squared is 36, and 36 is a perfect square. Okay? And we'll stop there with 36. All right? 36 can't go into 32 because it's bigger than it. All right? If we take 32 and we divide it by 25, that doesn't go in evenly. It's a decimal. Okay? So that can't be it. But 16, in fact, we know 16 went in because we put two 16s in to get the 32, right? We added two of them together. So 16 is going to be the largest perfect square that goes into 32. So what we do is we take our square root of 32 and we break it up into two square roots. 16, who's the largest perfect square that goes into 32, gets the first radical. Okay? 16 times 2 is how we got 32. So the square root of 32 is made up of the square root of 16 times the square root of 2. Okay? What we're going to do now is we're going to circle the square root of 16, and we're going to cross them out because the square root of 16 is 4. And so there it is. If you squish those together, okay, C, we could also have said, is 4 square root of 2. That has the same exact decimal value as the square root of 32, but it's in what they call simplest form. Okay? And so now I want to show you a little trick, that if the side of a square is 4, the other side obviously is 4, so that they're equal because it's a square, then the length of the diagonal is that side of 4 multiplied by a square root of 2 every single time. Okay, so I'm going to tell you a little bit of trick. All right, I'm going to show you off to the side here that if you have a square, and let's say the side of the square this time is 11. Instead of going through that whole Pythagorean theorem process to figure out the length of the diagonal, okay, that diagonal is just 11 square root of 2. Whatever the side is, multiply it by the square root of 2, and that's the length of the diagonal. It happens every single time. Just to show you one more, let's say you have a square, and let's say he has a side of, let's say, 98. So all sides are 98. And let's say that they ask you to find the length of the diagonal of the square. Instead of going through that whole process, the length of that diagonal is 98 square root of 2. Okay, so you just multiply the side by a radical 2 and you get the length of the diagonal automatically. So it's a cool little trick, okay? But make sure you use it correctly. All right, in number 2, it says in square ABCD, A, B, C, D, diagonal AC is drawn. How many degrees are there in the measure of angle ACB? A to C to B is this angle right here. Well, if you remember from up in our picture when we're talking about the properties, remember everything happens in the square because the square is everything. He has all the properties that we've ever talked about. So remember we talked about the property about the diagonal bisecting the angle? That 90 degrees is going to get cut in half. And when you cut 90 in half, you get 45. So not only is that question mark angle that we were looking for 45, but that's 45, that would be 45, and that would be 45. Okay, and so our angle ACB ends up being 45 degrees. Okay, all right, number 3. It says in the accompanied diagram, quadrilateral ABCD is a square. So we can go ahead and mark him up so we don't forget that he's a square. And they have diagonal DB drawn. Which of the statements is not true? All right, so let's go through each one. Number 1 says that AB, which is a side of the square, is congruent to CB. CB is the side of the square. And so this is 100% true. Okay, we're looking for not true though. So let's look at number 2. They said that AD, which is the side of my square, is congruent to CB, which is the opposite side of my square. Well, they're both sides of the square, so they're going to be equal as well because the square has all sides equal. Number 3, DA, which is my side of my square here, is perpendicular to AB. Okay? DA is perpendicular to AB. Well, hopefully you guys know that perpendicular lines form right angles. So are these two sides forming a right angle? They absolutely are. And so this is going to be true again. Okay? All right, last one. Hopefully this is it. AD, which is the side of my square, is congruent to DB, which is not a side of my square. That's the diagonal, aka the hypotenuse. The definition of a hypotenuse is that it's the longest side of a triangle. So there's no way that the hypotenuse can have the same length as another side of my triangle. And so this one right here is 100% false. Okay. In fact, if you just remember what we did in the question up above, remember how this was 4 and this was the 4 square root of 2. So 4 square root of 2 would be longer than 4. And so there's no way they can be the same length or congruent. One's going to be longer than the other. The diagonal will be longer than the side. Okay? All right, last question. Number 4, it says find the area of a square whose diagonal is 3 radical 2. Now, we haven't done hardly anything actually with area this year, but hopefully you remember something from previous years where maybe you found the area of a shape. Okay. So this is a square, and this time they're telling us the length of the diagonal. So if I draw in one of my diagonals, and again, it doesn't matter which one because they're both the same length. Diagonals are equal in a square. He stands up straight. They said that the diagonal here is 3 square root of 2. Well, if you remember my little trick, all right, a couple times I showed you that whatever the diagonal is, it's the side with multiplied by the radical 2. So if we take the radical 2 off, we're going to figure out that the side of the square is 3. Okay? And if you remember a little bit about area is equal to length times width, or base times height, like it is called on our reference sheet. Well, the base and the height of our square, the base is 3, and the height has to be perpendicular, which is a good thing that those right angles are there. The height would also be 3, and 3 times 3 is 9. And so it would be 9 units squared for my area. All right, backside of our notes are proofs. Actually, with just one proof, but we cut those out this year, and so these notes are finished. And so I will see you guys on the next day for some mixed properties. Just throw all of our properties together and make sure that you guys know which shapes have which ones. All right, I'll see you guys later. Bye.